And the question in my written testimony, which is only 6 pages, so I hope you'll read it, is focus your actions when there's a uncertainty and there's a risk associated with uncertainty, focus your actions on where there is certainty. And where there is certainty is that increasing the area of frequently inundated floodplain habitat at the right time will benefit species we care about, particularly salmonids. In terms of research, if we were to actually do things like the YOLO bypass, we could do some great research on the food web and turbidity benefits of the YOLO bypass. We hear a lot about flows really aren't the problem, food web is the problem, and we need to restore tidal marsh. Well, inundating the YOLO bypass could be a much better food web benefit, and they can get going on that relatively quickly. And in fact, the bypass does flood sometimes, and they should be able to mine results from that. Another thing that I don't think's gotten enough attention is, and this is this question about predation that some of you brought up earlier, is that one of the reasons fish are victims to predators is because the water is clear and it's very easy for their prey to see them. Having more turbid water by having higher flows so that you stir up some sediment and move it down the system with the fish is a way to obscure the natives from predators. And it's a way of giving the natives a competitive advantage, which is a much wiser way to approach the problem than pretending like you can actually control the number of predators. That's sort of a fool's errand. Inundating bypasses will increase not so much suspended sediment turbidity, but phytoplankton turbidity. And does this have the same kind of predator reduction, prey impacts on the predator success? Thirdly, with this issue of uncertainty, it seems that when you're dealing with public trust resources, the precautionary principle is the principle to go with. Not does it have an R-squared value of 0.99, but does the weight of the overall preponderance of evidence suggest that increasing flows or increasing floodplain habitat, is that what it is? And that's what we believe, and if so, we think you should act on that. And lastly, I wanted to share some decision-making criteria with you. This is some decision-making criteria that we've proposed as in part of BDCP, and we'll probably elaborate more at the next hearing. But when you're thinking about what actions should we move forward with, obviously you want actions that are going to have a large magnitude impact and a breadth of impact. Think about it. If you want to inundate floodplain habitat, you're not just talking about inundating floodplain habitat. In many cases, you're talking about increasing the flow along hundreds of miles of rivers and all of the impacts that would have from the reservoir down to the delta. Certainty of benefit. In the BDCP, we went through numerous analysis called the DRERIP, Delta Restoration, Delta Regional Ecosystem Implementation Plan analysis, where you rank different measures based on certainty, magnitude of impact, and reversibility or risk. The YOLO bypass was the only the only action of all the conservation measures recommended by the BDCP. It was the only one that scored high magnitude and high certainty of benefit. There are some risks associated potentially with mercury methylation issues, but one of the key things about the YOLO bypass is it's entirely reversible. You can create a notch in the weir, you can put a gate on it, you can open the gate, and if you don't like it, you can close the gate. If you go restore a tidal marsh, which I am all for, it's not nearly as reversible. And there are some concerns that of negative impacts associated with tidal marsh restoration. So it's not a panacea, as some would have you, some would argue to you. So just in case you forgot about how much floodplain habitat there used to be and is now, there was a lot and there's virtually none. If you think about how we have changed our system, the reduction in floodplain habitat is one of the single biggest changes in the system. I'm not suggesting we restore it all back, I'm just illustrating how much has been lost. Having a little trouble with there we go. Same story with the San Joaquin. Most of what we have left is managed wetlands for waterfowl. There were some questions earlier today about upstream floodplains and rearing habitat versus downstream floodplain in the Delta and YOLO. I think that was from Fran. There are a lot of things we can do upstream in the delta, excuse me, upstream in the rivers, and I didn't come prepared today to present on that. But when it comes to actual large areas of inundated floodplain habitat, it's really the lower end of the system where you have your biggest opportunities. That's because that's where there's the lowest lying lands that get inundated for a much greater frequency of time. And the Department of Water Resources, in one of the appendices to the Central Valley Flood Management Plan, actually did an analysis of where the area that could get inundated most frequently is. And this shows it for the San Joaquin system. And it's primarily in the lower end of the system where you get these darker blues where you can create floodplain habitat. One of the problems with these analysis, which illustrates why the various planning efforts, your planning effort and the Central Valley Flood Plan and the BDCP need to integrate, is that these maps of floodplain inundation potential were actually based on existing hydrology, regulated hydrology. Given that the flow regime is completely messed up and we have very few high flows in the spring, DWR said, how often will we get floodplain habitat and where would we get it? And not surprisingly, the answer was, we don't get very much at all, even if we set the levees back on both sides of the channel by a mile. Same story on the Sacramento. As you move further down in the system, there's a lot more darker colors. I won't go into these maps in detail, but this is something that I recommended staff take a look at. And the main deficiency with this analysis is it just assumes a static flow regime. What kind of floodplain habitat can we restore in the future with existing regulated flow regimes? And the answer is not a lot, and that's why we need to change the hydrology in the system. But unfortunately, when flood planners are making plans about where could we create floodplain habitat that will benefit fish, they're stuck in this mindset of they don't have any control over the reservoirs, so they just have to assume that they're going to get what the reservoirs are releasing. And then when they look at the project, guess what? It doesn't have a lot of fish benefits because the floodplains don't get inundated very often. So I guess it's not really worthwhile to set the levees back. I would say that that's the wrong answer that comes from fragmented planning. And just to kind of re-illustrate this point, I mean, this is just a graphic I got off the internet today. It's pretty obvious. The low topography of a watershed is down in the zone of deposition, and this is where the floodplains are, and this is where we need to create the large floodplain areas. There's a lot of important work that we need to do in the gravel-bedded rivers, reaches, which is called the zone of transport. And releasing high flows that will inundate floodplains are more likely to actually rework those channels and create more complex channel habitat. There's also an opportunity for rewatering a lot of side channel habitat, particularly on the upper Sacramento River. There's lots of important work that can be done upstream on those channels, and I look forward to phase 4 to present more on that. But and you can get some floodplain habitat up there, but by and large, the floodplain habitat that stays inundated for days and weeks is in the zone of deposition at the lower end of the watershed. So how can we increase floodplain inundation? There's really, as I was saying, two options: increase upstream reservoir releases and physically modify the floodways, levees, and floodplains to increase the area of inundation. This is what's happening to some extent on the Nags Ranch in the Yolo Bypass, and they're getting really great results. I don't think it's an either or, I think it's a both, and that we may not be able to afford the water that we once released historically to inundate floodplains, and we're not going to get rid of all the levees. So how do we optimize the water we can get increased from the reservoirs, released from the reservoirs, and the floodplain we can get by setting back some levees or modifying some bypasses, and we need to do some optimization of that.
John, you and I saw two different things, and maybe you know more about this certainly than I do, but when I saw the slide of the Nags Ranch, a considerable portion of that water came through the Ridgecut Slough by virtue of closing a floodgate in Knight's Landing, and that doesn't have anything to do with anything other than agricultural drainage. It doesn't have anything to do with reservoir releases.
I saw that as well, that it's very closely related to Knight's Landing Ridgecut drainage, and I'm a big supporter of the Nags Ranch project. I think it's a great project for learning about how fish use agricultural floodplains. But a fundamental problem is that how do you get juvenile fish actually onto the Yolo bypass? You don't send them down the Knight's Landing Ridge Cut, and if you do, they're hatchery fish, and equally importantly, we don't want adult salmon moving up through the Nags Ranch and up the Knight's Landing Ridge Cut to a place where they can't really spawn. So can we get some good habitat from the flows from Cache Creek, Puda Creek, Knight's Landing Ridge Cut on the Yolo bypass? I think the answer is yes, by some impounding. But you're going to have there's some potential water quality problems, which I understand are being studied. I don't think that that's going to be enough to actually send a signal to the Delta in terms of the fisheries and food supply. And I think that those actions to create more habitat through the west side tributaries in the Yolo bypass are good, but they should be augmented by notching the weir and letting water go down the Yolo bypass.
John, can you talk a little bit, I was looking through your comments and glad you got to it, because I know you've talked about, obviously, Yolo bypass, but also the South San Joaquin areas. Could you just talk a little bit more about where, because even in the map that shows what's possible, you know, you're not going to flood all those areas of Stockton. So the question is, where's the sweet spot of doing habitat restoration in a floodplain on the South San Joaquin, more specifically?
I don't think I have a slide. I don't have a slide of that today. I would say that between Vernalis and the Delta, that's the portion of the San Joaquin that I've evaluated. One of the benefits of doing it there is that all of the runs have to move through that reach. So that's one place. There are several places where you could set the levee back, and then the most promising opportunity down there is doing something to integrate BDCP and the Central Valley Flood Management Plan, is to build the lower San Joaquin River bypass. But there are some, it's more complicated than that. So I can't give you a simple answer to that, but I'll show you a slide that indicates that we need to do both flows and setbacks, and I can come to the next hearing with some model results from our hydraulic model that can show you where some of the better opportunities are in that reach.
Great.
I just wanted to point out here that what I'm basically talking about in number 2 here is a physical solution, and I think the concept of physical solution was first brought up before in the case of the Herminghaus case in the 1920s, and it dealt with water on floodplains, and the Herminghaus family was arguing that you shouldn't build a dam upstream because it was going to reduce the frequency of floodplain inundation, and they weren't raising fish out there, they were raising cows out there, and they were depending on floodplain inundation to irrigate the pasture. The state constitution, or somewhere along the lines, we came up with this physical solution. Look, you don't need to just release all the water down the river to inundate a floodplain. You can actually try to find a way to pump water out of the river. What I'm suggesting here is, in addition to increasing reservoir releases, some people say it's hopeless, we'll never have enough water to really inundate floodplains without draining all the reservoirs. I don't think it's hopeless. I think we can release more water from the reservoirs and do modifications to the flood bypasses that will, and the Yolo bypass is the most obvious physical solution. Something that very few people know is that the Fremont Weir used to be notched. And somewhere in the late 60s, early 70s, someone filled in that notch. You can go out there. These are the as-built drawings. You can go out there and see where the fresh concrete was poured. And I wonder if they got a permit from anyone to either modify the plan of flood control or to divert water away from the Yolo bypass and into the Sacramento River. In any case,
You think maybe it was DWR without a permit?
it might have been DWR out there. In any case, they're going to. We heard Ted Summers say that they might need to modify some water rights or get some permissions to actually send water through the bypass again, and hopefully the board can be helpful on that. So this gets down to an actual analysis of setting back levees on the San Joaquin River, and the blue line shows how much habitat you can get at different discharges. So along the x-axis is discharge and CFS. And it flattens out about 5,000 CFS because, as DWR was saying, they've done such a good job of building levees and riprapping channels, and so the water can't flow out there. If you removed all the levees down there, you'd get a lot more floodplain habitat. Is that realistic? No, but can you move some of the levees or set back some of them? We say that would be necessary to actually reduce catastrophic flooding and also to restore salmon. So if you look at the San Joaquin River here, this is from previous testimony I've submitted. In most years, you don't even get close to that 15,000 CFS in the spring months when you need it. And so you could set back the levees, but unless you change the flows here, you're not going to hit the 10, 15, 20,000 CFS that you need to inundate floodplains, even with lots of weirs and modifications to increase the frequency of inundation. This is an interesting slide that I showed in my last testimony, and unfortunately I haven't updated it, and I promise I'll update it by the time I see you next. But this shows the effects, in my view, of the delta EI ratio on flows in the Feather River below Oroville. And so the blue line on top is unimpaired, median unimpaired flows before Oroville. The dashed blue line is how Oroville was operated before the 1995 Water Quality Control Plan. And the pink and red lines show how Oroville has been operated ever since then. And this is very closely matched to what Tom Cannon was talking about in the last hearings. He called it the VISE, that on July 1st, all of a sudden you can start pumping more from the delta. So what happens? The reservoir operators, namely DWR here, don't release any water from the reservoir in March and April and May because they can't export it from the delta. And then when they know they can export because of the rules that the Water Board created, they game these rules and then they release the water and start like mad. So you get the highest flows of the year in July and August and the lowest flows of the year in March, April, and May. So this is an example about how the rules you set can actually change upstream reservoir area operations. And this is why you actually have to set rules, not just about the delta, but how flows are released from upstream reservoirs. Now this is a graphic, and I'll go into this in more detail at my next hearing. But this shows a way of measuring floodplain habitat. So on 1 acre here, the one axis, the y-axis, we have thousands of acres of inundated floodplain habitat. And you have probability of exceedance. And again, this is the existing floodway with a levee, and this is remove all the levees. And if you remove all the levees, what you find is you get a lot more floodplain habitat, but you only get it in 1 and 4 years here, or maybe 1 and 3 years do you get a significant increase. Well, if you're a salmon that only lives every 3 years, that's not really that helpful to the population as a whole. What we need is to increase the frequency so it's occurring more often. And that's why changing the reservoir releases is really important. We already get inundated floodplain during very wet years, but we need to make it happen in around 50% or more of years. And so that's what, if you change not only the levees, but also change the hydrology, you get not only an increase in acreage, but more importantly, you get an increase in the frequency of inundated area. And that's a very important metric for salmon, at least. So I wanted to go to the actual specific changes in the plan, and our lawyer, Richard Bruce Collins, recommended that I suggest it this way because you were asking for specific changes in the program of implementation. So here are I think this is in the section program of implementation, and I would suggest, perhaps this is a matter of changing objectives, which we've already argued for, but adding floodplain inundation flows or some kind of metric of floodplain inundated area and frequency under your objective of river flows. And then adding a 7th objective, which you already have, but one that you would revisit with your water rights authority, and that would be the salmon protection and restoration objective. So you have 6 listed today, and I'd suggest adding 2B and 7. One of the big problems with in our view is that no one's actually responsible or held accountable for doing anything. So in this case, we have struck the words, in the future, the State Water Board may amend, and instead we suggest you add the words, by a date certain, hopefully within the next 5 years or sooner, the board will complete water rights proceedings to change the water rights responsibilities of DWR and the Bureau. to really get at getting specific. Who's going to do it? When's it going to happen? And getting rid of words like may to the extent possible. Again, here we suggest sort of the same thing, but we've added quite a bit of new text to your implementation measures within the State Board Authority. And again, here we're asking that you require reservoir operators to evaluate opportunities that could increase the frequency of floodplain inundation, kind of optimizing how they can modify flood plans and modify reservoir releases. If you don't ask them to do it, they're not going to do it. And then we'll have a hearing sometime in the future when you can ask them to do it. Now's the time to ask them. Or B, under this, require that in developing the Bay Delta Conservation Plan, the DWR and the Bureau evaluate alternatives that employ the proportionate unimpaired flow approach. I think the board staff has asked them to do that. We haven't seen that run. The NGOs did work on a run that uses the proportionate unimpaired flow approach, and we're going to American Rivers is going to present that at the next hearing. But instead of all this hand-waving about how this isn't going to work, don't you think you should actually see some evidence of what this would look like before you allow people to say it wouldn't work? Also, under the rubric of BDCP, they really need to evaluate what the effect of the new intakes will be on salmonid populations that enter the main stem of the river downstream of Fremont Weir. There's a lot of talk about migratory pathways. We think that's great. The Yolo bypass is a great alternative migratory pathway. But if you're a fish from Butte Creek, the Feather River, the Yuba River, or the American River, in normal or even relatively high flow conditions below flood stage, you're not going over Fremont Weir because you come in downstream of Fremont Weir. So you get to run the gauntlet of the 3 new intakes. And there needs to be some analysis on how that's going to work. And is there some opportunity for floodplain restoration between Fremont Weir and the Delta? The city of West Sacramento is considering setting back a levee, but unfortunately their plan's not integrated into what BDCP is doing. They could set back the levee and create a lot of inundated floodplain habitat, but no one's putting those dots together. A couple more and I'll be done. Number C here, modify the water rights to provide for increased flows during the late winter and early spring on upstream rivers, particularly the Feather and San Joaquin. These are the ones where it's really clear that the flows are inadequate for many different reasons, particularly floodplain inundation during the spring months. There's all those good things that will happen along hundreds of miles of channels if you actually increase the flows, and one of those good things is floodplain inundation. And then lastly, modify water rights as appropriate to allow the diversion of water onto floodplains, particularly in the Yolo bypass. Thank you.
Great.
I would just like to remind you, Mr. Kane, and all those present, as we try and do our balancing, which Mr. Henry acknowledged is a challenge on a good day. We do have on these, we talk about floodplain inundations like it's a pretty simple thing, but there are, we've beaten the tar out of DWR pretty well here, and we've touched on the core. There are these projects that we're talking about inundating were originally put there for flood protection and not necessarily for habitat. So we're trying to find a balance where it functions as both. And that has a little bit to do with some of this hand waving that you're talking about, because it's not as simple as just providing additional flows for continual floodplain inundation, particularly when you talk about the Feather River. The levels it takes to get floodplain inundation in a lot of parts of the Feather are also levels that jeopardize human welfare of people that just happen to live along the river. So it's not quite as simple as just providing these flows. There are other considerations as well, not to say that those aren't some of the most functional considerations we've had, but how to make it all work in a balance is part of our challenge. And it has nothing to do with the difference.
In a way, it sort of makes my point. I think we've heard people say, well, we're going to restore floodplain habitat. Floodplain habitat's great. We don't worry about flows too much, floodplain habitat. Well, it's complicated to do floodplain habitat, and it's more complicated to do tidal marsh habitat. And then secondly, and which I forgot to say, is that the Central Valley Flood Plan does promote and include in its plan expanding the flood bypasses on the lower San Joaquin and in the Yolo bypass area. And so does the Delta Stewardship Plan, and it also promotes levee setbacks. And the Central Valley Flood Management Plan does this not just to make more fish, but to actually increase public safety. So there is a lot of room for setting back levees and to improve public safety. And in fact, our mantra at American Rivers is that public safety is number one, and that the best way to protect public safety is to give rivers more room to safely convey flood flows.
And I don't want to be argumentative here, but I am to a degree. When you look at the flood plan, part of the intent and the expressed intent was to expand these floodplains, but part of their intent was to reduce maintenance cost, which means they're going to expand the floodplain and do nothing about the vegetation that's going to grow in the centers of these channels to maintain it. That might be good for for habitat, but it isn't necessarily good for the original function of these plains. And we can argue about that till the cows come home, and I won't give up on that one. So, I mean, it's a sum and sum kind of a thing. You're touching on the portions you want to acknowledge, but there is something there again that requires a balance.
Okay, well, I won't argue that point.
I have a question in terms of timing. You talk about winter and early spring flows. Are you saying that it's more important to have these releases in the November, December, January, February time period than, you know, going, right now we're looking for spring releases in February through June, I think it is.
Well, you know, I often say spring, but actually spring doesn't start until March 21st. And so we are saying is February, late winter, early spring, February, March, April. I don't think it's very realistic to be inundating floodplains intentionally in June, and it might not even be good. So that's still in spring, June 20th, and I'm not advocating for that.
Thank you.
Thank you.
Yeah, thanks a lot. And also, thank you for all of the specific recommendations. That was helpful. And thank you, Richard, for your part.
Good afternoon. My name is Tom Cannon, and I represent the California Sports Fishing Alliance and the California Water Impact Network. I'm an estuarine fisheries biologist, and I have been involved in the Delta for about 35 years. I began my study of estuaries in 1972 in the Hudson River estuary, and the first paper I read was Turner and Chadwick, 1972. And that had a lot of great stuff in it, and it still applies, and people should go back and read it. It's 40 years old, but it's all exports and outflow. I'd like to speak to you today about what I know about the D1641 standards and the improvements needed in D1641. Sorry to put this slide up there again, you've seen it, but this is a different format somebody else tried. During the first years of implementing D1485, when I came to the Delta in '77, in 1978 it was obvious that the standards were not protective of the estuarine fish populations almost immediately after D1485. And export losses of Delta smelt during the spring and summer of 1981 were absolutely devastating, causing a complete crash in the population. Everybody wondered where they went. Well, if you go back to the salvage records alone through August, and you'll see where they went. Changes were needed and expressed in the draft two-agency 1982 two-agency agreement. It was a great agreement. DWR and DFG agreed on everything. And these same recommendations were put in the draft 1986 standards, and none of those agreements were ever implemented. I was involved in all of them. The core of the suggested changes was revised outflow and export standards. Many of the necessary changes did not come into effect until the 1995 standards. Monthly standards that had encouraged gaming the system, we talked about that before today, were changed to daily and weekly criteria. That was a major improvement. Many other badly needed improvements were also made in the 1995 D1641 standards. But one change proved devastating to the Bay Delta ecosystem, and that was the export inflow criteria. I'm just going to harp on that for the rest of my talk. The ramifications of this new standard for controlling exports do not
We're
rear their
getting tired enough, Tom, that if you repeat yourself 4 or 5 times, it might sink in. So give it
okay.
a try. Probably a pretty good technique.
Okay, the ramifications of this new standard for controlling exports do not rear their ugly head until the non-wet years of 2000 to 2004. Because, as you can see on the chart, 95 to 99 were wet years, and there wasn't a lot of exports. It was pretty nice. And there was a lot of recovery in the populations, including the Delta smelt. The basic problem was outflows were too low in the criteria and for spring and summer, and that was exacerbated by the unrestricted summer exports allowed under the EI criteria. In fact, from 2002 2004, they call that the pod period. I think the pod was caused by the export inflow ratio and the high summer exports. And I'll present some of the information on that. I can't present a lot. This problem didn't appear in the wet years of 95 to 99. Instead, under the wet conditions, there was a recovery for many of the species, including Delta smelt, longfin, striped bass. The problem with the D1641 standard surfaced only in those drier years with the high summer exports. I'm hitting you again. You can see it led to, in drier years, non-wet years, it led to the 6 million acre-feet of exports. And that's because you can pump 600,000 acre-feet in July, August, and September under the EI standards. Before, under D1485, the limit was 6,000 in June, 9,000, 8,000 or 9,000 in July and August. So you couldn't pump as much. And that level of 6 million acre-feet in those kinds of years is just too much. Under the EI criteria, exports could be maximized as long as there was sufficient inflow. We talked about that earlier, which only required releasing more water from the reservoirs, which was easy for DWR to do, as John just mentioned. The combination of increased exports, low outflow, and higher inflows proved devastating for the Delta fish and the estuary's low salinity zone on which the fish depend. I coined this last time as the VISE. If you increase exports and drop outflows and increase inflows to make up for it, you kind of have, what better word for it might be, a toothpaste tube, where you're pushing the low salinity zone and the smelt in their habitat out the end of the toothpaste tube in the South Delta. So the solution is higher outflows and lower exports. Based on my experience and understanding of the systems, I developed minimum outflow and export criteria that I believe will protect the Bay Delta fish and their food chain in the drier years like 2000 to 2004, and with some restrictions in years like 95 to 99. I emphasize the minimum criteria because these are not optimum. There will continue to be impacts even under these criteria. There's no doubt in my mind that these restrictive criteria are a must for spring through summer, especially in the non-wet years, if we want to restore the Delta and recover the pod species. I have these 4 charts for each of the seasons. The following 4 charts show the recommended criteria by season and water year type, with example years on the left too. Outflow is the most critical, as it is outflow that keeps the low salinity zone and most of the fish away from the influence of the pumping plants. However, in many years and seasons, it is not possible to maintain high outflow, thus the need for export restrictions. Even in high outflow conditions, fish can be vulnerable to exports during the residence in freshwater or during their migrations to brackish water or the ocean, and thus require protection from the higher exports. This winter chart, the recommended winter criteria reflect the need for protections in the dry periods by maintaining outflow and minimizing exports. Only after storms, which is the obvious case when you don't know what type of year you have, should exports rise above the base minimum of 2,000 CFS to moderate levels, but only if outflow and inflow also meet the specific criteria. Exports higher than 8,000 are simply too high, and they draw salmon and smelt to the pumps even in wet years. And especially when the Delta Cross Channel is closed. A lot of us have been talking about Delta Cross Channel, and I'm not in favor of keeping it closing the Delta Cross Channel, except under very high flows maybe. I'll talk a little bit more about that later. The spring chart, with many larval juvenile smelt and salmon in the Delta in the spring, criteria needed to be very restrictive to keep these vulnerable young fish away from the export pumps and moving toward the low salinity zone that should be in Suisun Bay at this time of the year. Outflows in the 8,000 to 12,000 CFS range will keep the low salinity zone in Suisun Bay, and low exports will minimize entrainment and salvage losses. I also recommend that the Delta Cross Channel be kept open, especially in drier years, as it is its closure that puts an unbearable burden on the East, Central, and South Delta and the San Joaquin River fish and the habitat in those areas from exports. Any young fish trapped in the Central Delta below a closing cross channel are essentially doomed to go to the exports. With the cross channel closed, fish and the low salinity zone are all pulled east from the Western Delta and Eastern Suisun Bay by the high negative net lower San Joaquin flows during the drier years. Oops. Early summer. Early summer is critical to many Delta fish species, especially the smelt and striped bass, as well as other pod species. Again, it's imperative that the low salinity zone be kept in Suisun Bay and exports restricted, and the cross channel open, especially at the lower flows. Oops. Late summer and fall, as in early summer, outflow needs to keep the low salinity zone in Suisun Bay away from the pumps. Export restrictions are greater in drier years to minimize the loss of juvenile fish to the pumps. Again, there's a chart with the pod. I believe the 1995 standards led directly to the pod. Because of the limited time, I'll only show you a few examples, but I've looked at every year, and every year applies. Right up to 2012. Oops. Here's June 2000, which is the first part of the pod, I would guess. Outflows were 8,000 to 10,000, down from the 20 to 30,000 in May. So the freshwater low salinity zone is moving upstream, and they're saving water in the reservoirs at that time probably, as the spring inflow declined. Inflows are still 20 to 22,000, and exports were 8 to 10,000, up from the 2,000 to 4,000 in May. The low salinity zone was in the Western Delta and moving eastward and down Old River towards Clifton Court 4 Bay. Much of the Central, South, and East Delta was too warm. That's the pink. That's above 22 degrees C for Delta smelt. They probably don't die till 24 or 25, but they don't do very well at 22. Warm inflow from the Sacramento River and San Joaquin Rivers is part of the problem. That comes with the high inflows to meet those export demands. Those waters from upstream are too warm. Under the recommended criteria that I have, June outflow would, for this above normal year, would be 12,000 for outflow, inflow of 20,000, exports limited to 4,000. That's on the bottom right-hand corner there. This regime would not only protect smelt, but decrease June exports 300,000 acre feet. I know that's a lot of water. I understand that. I've worked with the water contractors several times. But it would increase outflow 150,000 acre feet and reduce reservoir releases by 100,000 acre feet. So there's a lot of benefits to reducing these exports. And here's the distribution of smelt. In late June 2000, a lot of them are gone. And those big dots I call the end of the toothpaste tube. They squeezed most of it out already, and that's what's in the end of the toothpaste tube like we all are used to. And you can see by the link frequency, they're all under 25, and those are all entrainable. You will not salvage any of them, so you won't see them at the pumps. They're entrainable size. And so what we see there is what's left in the tube. The rest are gone down the pumps. And that was just June. I'll never get that right. So I'll jump to the end, 2004 in June, and I'll skip that one. That's just reiterating the same thing. Go to the real end, July. In July 2004, outflows were 6,000 to 7,000. That's way too low. Inflows were 22 to 23, high, and exports were 10 to 11. That's the problem, again, in all these years. These summer exports in July are way too high. The low salinity zone was in the Western Delta and Old River down to the Clifton Court forebay. I mean, really down all the way. The greater than 500 EC was all the way to Clifton Court, which means the low salinity zone was being entrained. Water temperatures in the East and South Delta were actually lethal, 24 to 26, and 22 to 24 in most of the other areas. So they can't even get to the Clifton Court forebay because they'll die before they get there. Only the lower Sacramento River Channel and Suisun Bay remain below 22 degrees centigrade. Under the recommended standards for a below normal year, outflow would be 10,000, inflow would be 16, and exports would be 2. This would keep the low salinity zone in the Western Delta and Eastern Suisun Bay. The recommended management regime would protect Delta smelt, decrease exports 500,000 acre feet. That's a big hit. Increase outflow 200,000 acre feet, a great benefit, and decrease reservoir releases by 300,000 acre feet. That's a lot of water. And that water can be used for storage and cold water maintenance. And here's the 2004 in May and June. You can see that back in May, the smelt were all over the Delta, Central Delta. And in June, they were starting to be confined up in the North Delta. Here's the salvage in 2004. Salvage at the export facilities for May through July in 2004 show that the vulnerability of smelt to the exports with a falling outflow and increasing exports. There's a chart like this on DFG's website for every year back 15, 20 years. The large peak at the beginning of June represents the loss of over 200,000 smelt in the salvage, which is estimated to be 1% efficient. And that's not even accounting for entrainment, and we already saw that most of the fish were below salvageable size. So you can just imagine how many smelt were being taken at this time. And few smelt are salvaged after late June because they simply cannot survive the warm water to reach the Clifton Court forebay. That's why you see the tail off. Never get that right. Threadfin shad, what are the pod species? In July 2004, threadfin were captured throughout the freshwater delta in the summer tonet survey. Threadfin shad tolerate the summer conditions in the delta, but they're still vulnerable to summer exports. There are several large peaks in 2004. I believe they are directly related to the negative lower San Joaquin flow. We've been talking about that because of the high exports. and the low outflows. So they're sitting there, and they're pretty much a freshwater fish. So they're sitting there all summer, vulnerable to these very high exports. And remember, these are the first time these really high conditions were occurring. And if you look at their distribution in the summer townet survey, in July, they're all over the delta, especially the eastern delta. And the surveys in August, there weren't any left, even though that's plenty good habitat for threadfin shad. So you can guess what my conclusion is there. The whole tooth-based tube is gone. American shad is another pod species. It also is a freshwater resident at that time of the year, and it has the same problem. High QS or negative San Joaquin flows. You get really high salvage and very high entrainment as well. And again, they probably have a very low efficiency of being salvaged. And exports reached 11,000 in mid-July, and that's when it all happened. And outflow was falling down to 4,000 during August. So July and August are important for these other species. A quick look at Eurytemera, the food of delta smelt and a lot of the delta fishes. Heard a lot about zooplankton. That's May 2004 and then June 2004. And the densities are 150th on the second chart. So they're practically gone. And there were a lot of them there in May. And you can guess what my thought is about that. And then the young Eurytemera, a lot of them there in May, and there's hardly any left in the tooth-based tube in June. Daphne, another important food. There they are in May 2004. And there's hardly any left in June 2004. And you don't want to look at July 2004 for any of these. And Neomysis is the other one, the important food for the fish. And all I can say is this is all I could find on them. The 5 pod years are definitely a decline in their population. And Neomysis pattern for the last more than 40 years shows that they used to be more abundant in the central and east delta. But after 95, there's hardly any left in the central and east delta. And that's because of the this is a summer index, spring and summer, and high summer exports simply take that population away from us. Delta smelt models, there's a lot of people say that they don't have a stock recruitment model very well, but this is one of the best stock recruitment models I've ever seen. And on the x-axis you have the fall index, and then the y-axis is the next spring's recruits of young. And you can see like most species, the main factor controlling them is the adult population. If you have a lot of adults, you get a lot of young, and if you have few adults, you get fewer young. And this is the stock recruitment relationship, and the red years are all the dry years, and the blue years are all the wet years. So you can see that obviously dry years are bad for the delta smelt population, especially this is a log scale. And the blue years are good, but even in a low population in the fall, the low adult population, you can produce some fairly good young the next year. And it's indicated in the summer index. And these are 2010 and 11, which generated the big recovery in the fall of 2011. And our 2011 population was right about here, and then it produced this in 2012. And we all know what happened in 2012. It's a really dry year, and things weren't very good. We talked about that last time. So really the potential for smelt is much higher. It's sort of like over by 2010 and 11. You can produce a lot of smelt, and but the dry years are bad. But even the good wet years are bad. I have an example here of 1999. It was a great year, still had a good index, but around the 1st of July in 1999, the exports went up, and we were in training 10,000 smelt a day. So that's, if you calculate the total, it's probably well more than 1 million a day. So that really knocked back, so you see 1999 here. You can see it's down here. It could have been way up here, which would have been 4 or 5 times the population, if it weren't for that huge loss in the summer, at the beginning of July in 1999. So we should have had exports of 4,000, but we had 11,000 under 1641. We should have had 20,000, but we had 25 pushing them in the tube, and we should have had an outflow of 8. They had outflow of 12. Instead, we had an outflow of 8. So these fish were very vulnerable to the VISE or tube. And we're talking about probably half or more of the whole population. But still, there was such a good recovery at the end of the 95, 99. There still were a lot of them left, and it wasn't such a bad year. And this is the other model where you use the young in the spring and compare them to the adults produced in the fall on the y-axis. And here again, you can see a very good relationship. The more young you have in the summer, spring, summer, the more you have in the fall index. And these were the poor years where we didn't have VAMP, and they got massacred in VAMP year, in the VAMP period without VAMP. And here's our friends in 2002 and 2004 with the dry year 1641 conditions. And then you have these little green years up here that weren't too bad because they were very low summer exports, and mostly because there wasn't much water then in those years after the drought. And here's 07 was a dry year with a high maximum summer exports. So the pod continued through 2010. My prediction for this fall is somewhere around here, and this was my prediction 6 months before last year, and I was right on. And the prediction with the model, this very simple model, would be here for the fall index, and that's where I predict it will be. Striped bass population dynamics, similar. Yeah, the striped bass population is operating down here just around below 1 million. And so in the dry years, we don't produce many young. In the wet years, we don't produce many young. So we probably all pretty satisfied with stripers being down here, even if they are hammered in their young of the year index by exports in the summer. Salmon, well, salmon are definitely salvaged, and a lot of them die in the salvage process or don't make it. Estimates are about 80% are lost before they get to the salvage. And so when you get low outflow, and high exports, you get a lot of salvage. So we still take a lot of fish, salmon, in the salvage under high exports and low outflow. And San Joaquin salmon, their numbers over the years are these blue lines, these blue bars, and that April, May, San Joaquin inflow to the delta or outflow from the San Joaquin is the purple. And they're very closely related to spring inflow to the delta. It carries into and through the delta. And that's a very significant relationship. And so unless they get a lot of flow, their chances of creating many salmon are pretty minimal. And I did the residuals on those regression models, and the residuals were statistically significantly related to export levels. So the higher your export level, the lower than expected salmon production conclusions. Outflow criteria are too low in the non-wet years and summer of wet years for the fish, their food supply, and their low salinity habitat. Export criteria expressed as export to inflow ratios do not protect delta fish, their food supply, or the low salinity habitat from being exported from the delta. Direct effects of low outflow and high exports also translate downstream into the bay in the form of lower bay inflow, less nutrients, fewer organisms, and reduced low salinity zone productivity. Specific export and outflow criteria are needed to protect the beneficial uses in the Bay Delta.
Any questions? Thank you very much. Will the next panel come up, please? They lost me. I had to. Doesn't take long, but I had to. Oh, yeah. We're having lunch on Wednesday, I hear. I always look forward to good company on lunch.
Yeah, good afternoon, Mr. Hoppen. David Guy with the Northern California Water Association. I'm going to be introducing Mr. Latour here. If I could, of course, it's been a long day, and you can see everybody's getting a little weary. We're obviously going to try to be efficient with the time today, but I think some
Or you
important
can be really
grounds that we
funny, one
cover.
or the other. I don't want to put any pressure on.
What's the pressure? Yes, exactly.
David, before you get
Yes.
started, a couple of my colleagues had to take a phone call or something real quickly, and they'll be back. One of your presenters today is not here for reasons beyond your control and his. How do we handle that? I mean, it's...
Yeah, if I could, Mr. Vogel had some surgery last week and had some complications from the surgery and just simply couldn't be here today for medical reasons. Boy, we would sure appreciate the board considering something like having him an opportunity in Workshop 3 to be able to add on or something to that effect. I will say that we were very excited for his presentation. He has 30 plus recommendations on salmon that are very specific on ways to move forward, and I think the board would benefit from that. So to the extent you could accommodate that in Workshop 3, or if you have a better option, we would sure appreciate that.
Rather than just give you an answer on the fly, we
Yeah.
will do whatever we can to accommodate that, David. I realize it's circumstances beyond your control or his, so.
Yeah, thank you. If I could, let me introduce Dr. Rob Latour. Rob is a PhD got his PhD at North Carolina State, and what is interesting is he's coming today from the Virginia Institute of Marine Sciences, which is part of the College of William and Mary. And I think what you're going to see is that Professor Latour is going to, I think, provide a fresh perspective on some of the data analysis with respect to flows. And I think that fresh perspective is going to be informed by a couple of things that I think are going to be helpful for this board and the folks around it. The first is that Virginia separates their science program from their regulatory program, and Mr. Latour, I think, is really in the core of that science program, and I think provides some really good perspective there. And the fact that he's worked in the Chesapeake and other systems, I think, provides some real added value to all of us that work in the Bay Delta today. His detailed bio and CV is in the packet. You can see lots of pedigree, lots of publications, but I think we're just excited that Mr. Latour is here today from Virginia, and hope that you'll have some opportunity to hear him, and then ask some questions as well. Well, if I could also, Walter William Beret III is also here today and as a resource for questions. He's not going to be speaking, but to the extent that there's flow-related questions, hydrodynamic questions, he is here. And yes, his middle name is important.
I feel sorry for Mr. Beret because I too am a third, and people in their English always want to put a U in it and replace the I, and I don't understand why. Think about it. Go ahead, Dr. Latour.
Well, thank you. It's been a long day, but an interesting one. Lots of interesting information come across the screen, so I appreciate the opportunity to speak. Hopefully this will aid in your decision making in the future regulatory regimes that you're contemplating. David sort of stole my professional background slide, so I'll briefly go through it. But there is some relevance, I think. Although I'm new to the area, I'm not new to this process. I do this quite a bit in Virginia. As a professor at VIMS, VIMS has a 3-part mission. This is codified in the Code of Virginia. We are asked to conduct research, educate students, and advise the Commonwealth as well as the public on regulatory proceedings. We accomplish the research and education through the connection with the College of William & Mary, so we are the School of Marine Science for the college. We accomplish the advisory service because we're also simultaneously a state agency. The forefathers of Virginia wrote in the code that the regulatory and the science process would be separated. So this puts us in a unique position relative to other institutions across the United States, I think. We have all 3 components in one house, without the regulation also in the same house. So you might ask, how does an academic survive when the deans want to count the dollars you bring in and the publications you have and the students you graduate? When at the same time we have lots of mandated state and sort of local regional fisheries monitoring programs that need to be executed for support of harvest regimes, et cetera. So in the fisheries department, we do implement lots of fish monitoring programs. We oversee them in all aspects. We interpret their information for regulatory proceedings. And the way we've effectively done this to merge the academics and the research is we view the fish monitoring programs as platforms for research, and we bring our students into those platforms and we allow them to add on as sort of a leverage value-added kind of approach to support their research. At the same time, we preserve the notion of what the surveys are providing for management. I highlight 2 here at the bottom of the slide. These are 2 programs that I've actually designed from ground zero and implemented. The first is operating in the main stem bay here. If I can get there we go. The main stem Chesapeake Bay. It's a groundfish trawl survey rooted in sort of ecosystem fisheries-based management to support those efforts that are ongoing in the bay. And the other is a coastal program ranging from North Carolina to Massachusetts. I've slogged around for 30 days on the vessels cutting fish. I've analyzed the data. I've designed the sampling programs. I've somehow managed to keep them funded for the last 15 years. So in this economy, that's been fun. Incidentally, VIMS is located right here, and if you're ever in Virginia, come visit us. We're right across the river, the York River here, from Cornwallis's Cave and the Yorktown battlefield, so there's a deep, rich history here. Maybe we can go out on the water and steam some crabs. These next 2 slides are sort of a mixture of observations, analyses that I've conducted over the last several weeks and months, and sort of ideas about future directions. This is admittedly focused on the fall midwater trawl survey data set. Observations about the data set as it relates to understanding the role of environmental covariates and explaining fish abundances. The first observation I have is I'm confused by the the units of the indices of abundance by DFG. They're average fish caught times water volume. I have a hard time understanding what that is. Most often indices are expressed as average catch per tow or average catch per volume or average catch per area, something along these lines, so that the indices themselves have interpretable units that can be traced back to the sampling program that can then be expressed or possibly scaled up to population level inferences. We can fix that, it's not a big deal. I was also sort of shocked a little bit that there haven't been, at least as far as I could tell, attempts to introduce and understand the role of environmental covariates at the underlying raw data set level. I'll mention it again in a little bit, but most of the relationships you've seen take indices of abundance, relate them to environmental variables, make inferences from there.